Hi everyone, this is our new chapter, mixtures. We are going to talk about concentration of mixtures, their separation techniques. So let's start. First, let's look at the classification of mixtures. And before that, in fact, we're going to look at the difference between the mixture and the pure substance. When two or more substances come together without any chemical change, they produce a mixture. Every pure substance of the mixture is known as a component. For example, if you have a salty water, salt and water are the components of that mixture. So let's examine the given changes. The first one is a chemical change because there's a new substance produced. This is a compound, a pure one. So in the second one, you have sodium chloride as a solid form. You put it in water and produce salty water. So this is a physical change. And the product, in fact, is a mixture. So what about the properties of mixtures? They are produced by physical changes. So they are separated into their components by physical changes also. They don't have specific formula or symbol. When I say oxygen, you tell me that this is O2, or when I say water, you tell me that this is hydrogen 2, oxygen 1, but salty water doesn't have a name like this. They don't have constant mass ratio between its components. It depends on you. They show the properties of their components. When you drink salty water, you feel the taste of that salt. They don't have constant boiling and melting point. It depends of the solute per solvent. They are not pure, so they can be heterogeneous and also homogeneous. Opposite of these properties can be considered for what? Of course, for compounds. The solutions that conduct electricity, maybe you remember it, they are called as electrolytes. What about the common properties? Mass is always conserved. Do you remember the first law of chemistry, law of conservation of mass, Antoine Lavoisier? They have more than one type of atom, compound and mixture one type of atom, and volume may not be conserved. This is important. When you add some liquid into another one, volume may not be conserved. The same thing is valid for the mixture for a solid and the liquid. Types of mixtures. A human eye can see the particles up to 0.1 millimeter, which is 10 to the power of minus 4 meter in size. This means that sometimes the outlook of the mixture won't be enough in order to call it as a heterogeneous or a homogeneous mixture. And in order to decide this, microscopes are used. Homogeneous mixtures. What is the other name for homogeneous mixtures? They are solutions. In these mixtures, you have a diameter of a particle smaller than 1 nanometer. Remember nanometer? This is 10 to the power of minus 9 meters. If a mixture has identical look and property, same look won't be sufficient, also the property, it is said to be homogeneous. And a homogeneous mixture, which is a solution, is composed of a solute and a solvent. And heterogeneous mixtures usually have diameter larger than 1000 nanometers. And in this case, the mixture does not have the identical look and property all over it. And you have some other types of mixtures called colloids, like blood, like fog, like jelly, or dyes. When you look at them, you see them like homogeneous, but when you just look at them and investigate them under a microscope, you're going to see that they are heterogeneous. Classification of solutions according to their physical states. For example, solid, liquid. What can you give? Example, salty water. Liquid and liquid. Alcohol plus water. Let me give another example. It is going to be benzene plus carbon tetrachloride. Benzene is something non-polar, liquid, and this is also non-polar, so they are going to be dissolved in each other very well. Liquid and gas, coke, solid, alloys like brass, like solder, like steel. And gas, the most probable example is air. There cannot be any heterogeneous mixture for a gas one. This is important. Please do not forget. Classification of solutions according to their concentrations. Now remember, we have already told it. A solution is composed of a solute and a solvent. The solute is the substance that is dissolved, and the solvent is the substance that dissolves that solute. And we have another term, this is the new term for this year, called solubility. So this is the maximum amount of solute that a specific amount of solvent can dissolve. So how would we just classify them? As saturated, as unsaturated, supersaturated, like jams, honey, marmalades. And if you like, you can just divide unsaturated into diluted. This means that you have really high amount of solvent and you have high amount of solute. In fact, you cannot use these terms in order to classify one solution. You can use these terms only to compare the solutions. One solution can be more diluted than the other one, or one solution can be more concentrated than the other one. What about the types of heterogeneous mixtures? Heterogeneous mixtures are composed of dispersion medium and dispersed phase. Dispersion medium has a higher amount than dispersed phase. Let's look at the examples. For example, if you have a liquid aerosol, you have a dispersion medium as gas here and dispersed phase as liquids, like the deodorants, sprays. Dust, this is known as solid aerosol. In this case, you have dispersion medium, again gas, but you have solid as a dispersed phase. So when I told you you have an aerosol, then you're going to understand the dispersion medium is always going to be gas and dispersed phase can be different. If it is liquid, then this is known as the liquid aerosol. If this is solid, this is known as the solid aerosol. And also paint. In paint, you have liquid as dispersion phase and you have solid as the dispersed phase. Now, what kind of examples can we give for heterogeneous mixtures? Solid. For example, liquid, you have oil plus water. What was the other name used for it? It was emulsion. Solid liquid, scent plus water. The other name was suspension. Solid. Any kind of mixture can be solid. For example, iron dust plus sulfur dust. Gas liquid, like the sprays we have already told it, known as liquid aerosol. And gas solid, you have dust known as solid aerosol. Okay, now just look detailedly for the homogeneous mixtures. Now, what do these pictures represent? The first one represents sodium chloride dissolving in water. Now you see some there pluses here, you have minuses here. These pluses just represent the sodium plus ones, so these chlorines are minuses are chlorine minus ones. Now this is sugar, carbon 6, hydrogen 12, oxygen 6, and these are water molecules. So what are the difference between them? This is a molecular dissolving. This is an ionic dissolving. Now, what about their interactions? The first one has an interaction of ion dipole. This one has an interaction of hydrogen bonding. You have dipole, and you have London forces. And what was the rule for dissolving two substances in each other? It was like dissolve in like. So polar substances can be dissolved in polar solvents, where the nonpolar substances can be dissolved in nonpolar solvents. Now, what about the concentration of the mixtures? The first one, mass percentage. It is mass of solute over mass of solution times 100. Now, what about volume percentage? This is volume of solute over volume of solution, again times 100. Now just be careful. I have put a be careful sign here, because when you sum the volume of two solutions up, probably you're not going to find the direct answer. For example, you have 50 milliliters of water, 50 milliliters alcohol. We're going to neglect some amount of loss in volume here and tell that 100, but please know that volume may not be conserved. What about mass per volume? This is mass of solute. In fact, this is the combination of first two over volume of solution times 100. This just looks like finding density, mass per volume. Now ppm and ppb. Now they have two situations. They can be asked by mass or they can be asked by mass per volume. ppm means parts per million. It is just like finding the mass percentage of a solution. In this case, if the by mass is asked, you're going to look at 10 to the power of 6 grams of solution. You're going to use that one. But by mass per volume is asked, you're going to find amount of solute that is dissolved in 1 liter of solution. And just be careful, the amount of solute should be used in terms of milligrams, not grams, not kilograms. If this is ppb, parts per billion, in this case you're going to look the amount of solute per billion grams of solution, or if mass per volume is asked, you're going to find amount of solute in 1 liter solution in terms of milligrams. Now remember, 1 milligram is equal to 10 to the power of minus 3 grams, where 1 microgram is equal to 10 to the power of minus 6 grams. Now there is another term called as the colligative properties. Now colligative properties of a solution means the properties that depends on concentration of a mixture. For example, when you add some amount of salt into the pure water, freezing point of the water decreases where the boiling point water of the increases, and you have another event called osmosis. Now this is the osmosis event. This is the part with low concentration. This is the part with high concentration. After a while, some amount of water is going to be transferred to the second one in order to equalize the concentrations. Then you're going to see finally there is a rise in the right hand side where there is a just going down on the left hand side. And at this point, the concentrations are equal. So we call these solutions as the isotonic solutions. Now the separated methods. First, based on the particle size. Picking up. You're just taking the unwanted substances from rice, let's say. You can use this picking up by looking at their sizes, by their colors. It's a separation method used a lot. Sieving, sand sieving. Filtering, sand and water. Or you filter the air in the room, for example. Air filtration systems are also used. And the last one is dialysis. Dialysis is used for the people that have non-working kidneys. Now, separation methods based on density difference. The first one, precipitation. It's a method for separating homogeneous mixtures, mostly aqueous solutions. If the precipitate to be formed is big enough, we use beakers. But if they are not that big enough, we use a system called centrifuge. And mostly in laboratories, to analyze blood, centrifuge systems are used. Next one, decantation. After the precipitate, the liquid that is on the top is removed from the precipitate very carefully without forming any turbidity. This is called decantation. And we have flotation. We used to separate them, for example, sawdust and sand with the help of the water. You put water into them, and where sawdust flows and sand sinks. For example, this is an example for flotation. It is used in the recycle of used paper and separation plastics from glass, soil, stone, and garbage. It is also used in mine industry in order to purify ores like lead, zinc, and copper. Now, what about the separatory funnel? We use it to separate two liquids that are immiscible with each other. Separation methods based on solubility difference. First, crystallization. In order to use this method, the solubility of the components of the mixture should be changeable. The component which will be separated must have high solubility, at high temperatures and low solubility at low temperatures. Second one, if there are two salts in the same solution, then fractional crystallization is used. It depends on the change of solubility with temperature. Salt and naphthalene mixture can also be separated by using their solubility differences in water. And there's a new one called as the extraction. For example, Turkish coffee or making tea is a kind of extraction. The main substance used in making aspirin is obtained from willow tree by extraction. Also in the production of perfumes from flowers, extraction is used. There are two types of extraction. One of them is liquid. The other one is liquid solid extraction. Separation method based on boiling point difference. For example, if you have salty water and you have to separate salt and water in two different containers, then you apply distillation. This is known as also as a simple distillation, but saying direct distillation would be enough. Now in this case, you have your mixture here and you boil it, and after a while there is water vapors coming up here and they are just going through this condenser, and in this condenser there is cold water passing through. So when the vapor just meets with the cold area, this is going to be condensed. So here you have the water vapors, and in this case you have drops by drops water here. So after a while there's going to be salt only here and water only here. This method is called condensation. And if you just use this for two liquid mixture, liquid homogeneous mixture, this is called fractional distillation. We mostly use fractional distillation during the getting different types of fuels from petroleum. Here is the example for petroleum here. Here is the example of petroleum here. So when you distillate the petroleum, you obtain fuel oil, diesel, kerosene, or gasoline, different kinds of fuels. But the working principle of it is just the same as distillation. You just boil that let's say alcohol and water here. After a while alcohol is going to be vaporized and it's going to meet with the cold weather here, cold air here, and it's going to be condensed. So the one who has the lowest boiling point is going to be vaporized earlier and be condensed in this collecting container. So what are other separation methods? Electrification. For electrification you need ebonite and some woolen clothes. And if you just like to use magnet, you can use magnet for the metals iron, cobalt, and nickel. And if you just like to obtain a gas from a gas mixture, first you condense all the mixture and apply fractional distillation.